Hello class, today we're going to be on 1.2, finding inverses algebraically and graphically. So our unit is on inverses. Remember what we talked about inverses. They undo each other. They're the opposite function. So say if I have an inverse that does one thing, say if I have a function that does one thing, its inverse undoes that one thing. So let's first talk about how to find inverses algebraically. So let's start off with the steps, I suppose. So let's see. Actually, we should probably. So to find inverses algebraically, steps. I'll do it over here. Steps. The first step that we want to do is we presented it in an f of x form, function notation. Just turn the f of x into y. And the only reason that we want to do that is that it will make our algebra a lot easier and cleaner looking. So turn f of x into y. And then step 2, we want to switch the variables. So y becomes x, x becomes y. So switch variables and solve for new y. And then finally step 3, we want to turn our y into f inverse of x. So just turn it back into the function notation that it originally was in. Let's take a look at a couple examples here. And we're going to start off with something like this. F of x equals 2x minus 3. And I want to find what is the inverse of f of x. Well, if we follow these 3 steps, we should be able to find it no problem. So step 1, turn f of x into y. So I'm going to just rewrite it. And again, this is just to make it look a lot nicer when doing the algebra. Otherwise, the f of x looks a little clunky and it kind of confuses us. And then now we want to switch the variables. So y becomes x and x becomes y. We don't want to switch these. X equals 2y minus 3. And then now we want to solve for our new y. Well, this is going to kind of bring us back into the idea of solving for variables. Right? We want to get the term with the variable by itself first. So let's move this 3 over. The 3 is being subtracted, so let's do the opposite operation to add 3. So we're going to add 3 to both sides. And let's see. This will cancel, which was the point. And on the left side now we have x plus 3 equals 2y. Now that the term with y is by itself, we want to get y strictly by itself. Now y is being multiplied by 2, so we want to do the opposite operation of multiplication, and that is division. Let's divide both sides by 2. That will cancel this 2 out, which is the point. And y equals, well, we can't really simplify this, right? X isn't divisible by 2, 3 is not divisible by 2. So to make our life a lot easier, let's just leave it in this form. So we're just going to leave it as x plus 3, all divided by 2. And it's important you put the line under both of these terms, x and 3, because 2 is being divided, or this whole thing is being divided by 2. So now that we have solved for our new y, our last step is just turn y into f inverse of x. And I'm just going to kind of switch this. Remember, it doesn't matter what side things are when we're talking about equalities. So I'm just going to move this y over to the left, just so we can write and switch it to f inverse of x. So f inverse of x is equal to x plus 3 equals 2. So again, all I did was I just, like, this went there, and that went over there. I just switched it. You can do that. That is fine. And this is the inverse. X plus 3 divided by 2 is the inverse of 2x minus 3. It's pretty cool stuff there. Let's take a look at another example before we move on. And this time, let's say that we're going to call this one g of x is equal to x minus 9 divided by 3. So again, our first step is turn f of x, or in this case g of x, into y. So y equals x minus 9 over 3. That should be a 9. And then we want to solve, and then now we want to switch our variables. So x becomes y becomes x. And we have x equals y minus 9 over 3. And now we want to solve for our new y. Now, we want to get y by itself, and last time, the first thing that we did was we moved the 3 over, right, to get the term 2y by itself. And you may be thinking, oh, well, let's just add 9 to both sides. Well, we can't just yet. And the reason is because this whole thing is together and it's being divided by 3. So let's get rid of our fraction first. Whenever we see a fraction, kind of rule of thumb, not always, but usually, and always in this case, we'll want to get rid of the fraction first. So it's being divided by 3, so let's multiply both sides by 3. Now this cancels this out, which was our point. And now on the left side, we have 3x equals y minus 9. Almost there. Now we have this 9. Now we can add both sides. Or 9. We can add 9 to both sides. So this cancels. That was the point there. I guess cover it. And now we have 3x plus 9 equals y. And you may be asking yourselves, well, why can't we combine 3x and 9? Well, because remember, we can't combine terms that have x's and constants. Remember, constants are just numbers. So we can't combine those, so we're just going to write it just like this. And then finally, last step, turn y into f inverse of x. And again, I'm going to put the f inverse on the left, just so it kind of looks nicer. Oh, sorry, we're working with g, aren't we? G inverse of x equals 3x plus 9. And that's it. 3x plus 9 is the inverse of x minus 9 over 3. And you'll start seeing this pattern. You'll start seeing a lot of the same numbers. And in fact, they will have the same numbers. They'll just be in slightly different order. That's kind of the point of inverses. So let's move on. Let's talk about how to find inverses graphically, because that was the second part of what we're doing today. So let's write this: to find inverses graphically. So there aren't really steps to do this, because when we look at graphically, we're just looking at it, really. But to find inverses graphically, we want to recall this idea. Recall that if we have something like f of x is equal to y, then the f inverse is really like switching the x and y, right? We did that when we were working algebraically. We switched the x and y. So f inverse is really like saying y is equal to x, although we call it x still. You'll see it written like this: f inverse of x, right? You'll see it written like that, but really it's the y of the original function. So using that idea, let's take a look at a graph. let's say that we have this graph right here. And we are tasked, we want to find f inverse of 2. Well, think about what f inverse of 2 is. This 2 is not, normally when we have something like this, f of 2, this is an x, isn't it? But remember the f inverse, when we're talking about f inverse of 2, that's really a y. So what we want to do is we want to look at our y-axis. So maybe we can write that up here. To find inverses graphically, look at y-axis and then find the corresponding x value. So let's do that. Remember, the y is the vertical, x is the horizontal. So to find f inverse of 2, what we're going to do is we're going to find 2 on y, which is right here, and kind of go out horizontally, and then until we get to our function, and then think, okay, what is the corresponding x value? Well, the corresponding x value is right down there, right? And what is that value? Well, 1, 2, 3, 4. So to find f inverse of 2, it is equal to 4, right? The y is equal to its x. So let's take a look at another example. This will be our last example here. So let's say we now have this function, and we want to find f inverse of negative 4. Well, let's recall this idea that we are, when we're talking about negative 4, we want to look at our y value. And so this negative 4 is really a y value. We want to find what is the corresponding x value to this. Well, we're just going to count down to our negative 4. Remember, negative is in the down direction. We're talking about y's. So negative 1, negative 2, negative 3, negative 4. We're going to go out horizontally to our function and then kind of see, okay, what is the corresponding x value? And it is right here. And what is that value? 1, 2, 3, 4. So again, our answer is, in this case, let's do it in the same color, 4. So that's all we have to do when looking at it graphically. Get started on your worksheet. Let me know if you have any questions. You'll have questions that ask you to find the inverses algebraically and then finding them graphically. So I'll be here if you have any questions. Have a good day.